Hey guys, what is up? It's your pal Dave back in the lab for part 2 of the project codenamed Cheetah. Now we have to give it a code name because this is a morally questionable project. Should cheaters be allowed to prosper? We'll leave that up to the historians, but we're going to proceed anyways. So if you missed part 1 of this project, we're building a little device that sits between your MIDI keyboard and your synth and translates your random key flailings into actual music that will impress people. So let's dive in and see where we're at with this project. But before we start, we got to give a quick thanks to our wonderful sponsor, Skillshare. Skillshare is an online learning community with thousands of classes for creative and curious people. Learn new skills or deepen your existing passions. I'm especially interested in the programming, electronics, and music classes, and Skillshare has hundreds to choose from. I found a really cool class called Introduction to Arduino, Creating Interactive Projects by the founder of Make Magazine, Mark Fraunfelder. I think this is a great class for people getting started with Arduinos. Skillshare is designed for learning, so there are no ads to break your concentration. And it's less than $10 a month with an annual subscription. Also, check out the link in the video description, and the first 1,000 viewers will get a free trial of Skillshare Premium. So thanks again to Skillshare. What I basically have going here is a MIDI keyboard using 5-pin MIDI out into our Cheetah project. The Arduino is doing all the processing. It then spits the notes out of here. Now, normally I would connect it directly to the synth, but what I've done is I've used this MIDI interface that is connected to my computer, and that's going to intercept the messages and allow me to view them on a MIDI monitor, which is very helpful. And then finally, those notes will be passed through and into our synth, which will play the notes. So if you notice, I've added some buttons to the device, and even though I've got a bunch, I'm only using these 3. So I'm going to have one button for major, one button for dominant 7 ideas, and one button for minor ideas. So the way I want it to work is that you can play it like a normal keyboard. And then when you want, press one of the buttons and it will enable the cheat mode. Now remember, the lowest note you hold is going to determine the key of the licks that will come out. And there you go. And then when you release the button, you're back to normal. So it's a little inconvenient to have to reach and push a button. So what I will do is I'm going to replace these buttons with foot switches and put this whole thing in a box that you can put on the floor and just step on it, and then you can keep your hands on the keyboard at all time, and that will add to the illusion that you know what you're doing. Now here's a little challenging part to this project that I had to overcome. If you know anything about MIDI, you know that it's based on note on and note off commands. So when I press a key, it's going to send a note on message with that key number to my synth. My synth will react by playing the note, and it's going to keep playing that note until it receives a corresponding note off message with the same note number. So over on this window here, I've got a program called MIDI Aux, which is a really great MIDI monitor program. So it's taking the data from my MIDI interface and it's showing me on this screen here. When I press a note, so let's press, say, this middle C here. So you can see we get a note on command. 90 is MIDI for note on. The note value is 3C, and the velocity is 7F, which is the highest velocity. And when I take my finger off, there's the note off message. So 80 is MIDI note off. The note is 3C again, so that's going to cancel that one, and the velocity is 0. So as you play, you notice it's always a pair of note on and note off messages. Now let's say I play a chord, 3 notes. Okay, there you can see I'm holding C, E, and G. And when I release them, 3 note off messages. And I can release them or hold them in any order. So let's hold that chord again. Now I'm going to release 1 note, the middle note. Then I'm going to release the G, and then I'm going to release the C. So here's the challenge. When I'm playing normally, I'm going to have various note on and note offs happening at all times. When I hit the button to turn on cheetah mode, I'm going to have to make sure that I clear all the notes that are currently being held. So the way I handled that was to create a buffer of 10 notes. This buffer keeps track of all the notes that are being held at any given time. And when I enable a cheat mode, it's going to send commands to turn off all those notes. So let's say I'm in normal mode, I hold a C major chord, and then I enter a cheat mode. You notice that the cheetah sends the corresponding note off commands. And one of the challenges with programming MIDI code is you can't use the serial line to troubleshoot your code and to look into your variables. So Arduino, you can use the serial output and the serial monitor in the Arduino software to keep track of your variables and stuff like that. But when you're using MIDI, you're basically tying up that serial line, so you can't use the serial monitor at all. So I was thinking, like, how can I check my variables using MIDI? And then it came to me. MIDI has a message that basically can hold any information you want, and that's called a system exclusive message. And a system exclusive message is basically a message that has really no parameters other than it needs a certain start bit and a stop bit, but all the bits in between is up to the manufacturer to decide how they want to do it. So I figured, why don't I use that, a system exclusive message, to view what is going on in my MIDI buffer, and it works really well. So let's take a look at how I did that. Okay, so let's take a look at the code, and we're going to take a look at what I was talking about, how to use those system exclusive messages to check on your variables. So here's the code, Alpha 2, still early stages for this code. You notice I now have 3 bytes for the different licks. So I have the minor ones in here, the major ones in here, and the dominant licks in here. Now I'm going to add and increase these so you get more and more licks. But for now, I just wanted to make sure it works. So I got 3 for each type. So the interesting part is this new function called button update. And we also have our MIDI read command that is checking for any incoming MIDI messages. So that's important that you call that frequently. Okay, so if we go down to note buffer, you notice that this function takes 2 parameters. One is byte, which is the note in value. So that would be the MIDI note number that comes in. And then we have this Boolean, which is a true or false variable, which if it's true, that means the note is in, that is coming in, so put it into the buffer. And if it's false, that means it's a note off, take it out of the buffer. This function will also return a variable, so it will return true or false. It will return false if the buffer is full. So like I said, there's a 10 note buffer. And if you try to put more than 10 notes, it's going to say buffer's full, sorry, it didn't go through. If it returns true, that means, yep, the note went into the buffer and everything's good. So here's the variables for this function. We have our buffer array. So you notice this is a 10 byte buffer. We also have this how full variable, which is going to keep a running track of how many notes are currently in the buffer, so we can tell if the buffer is full or not. So one important point for you new programmers is this static keyword here. So when you make a function like this, every time the function is called, it will create these variables brand new and set them to the initial value you give. And then when the function is done, it will erase those variables and free up the memory again. But we don't want that. We want to keep track of how many notes are in the buffer and what the buffer contains, even when this function finishes. So by using the static keyword, it means, hey, don't get rid of this variable. Keep it. Even when the function ends, keep track of that variable. So this is very important, the static keyword. Okay, so if a note comes in, we'll know that because our note in parameter will be true. And if we get to this, so note in equals true, so that means it's a note coming in or a MIDI key has been pressed. And also, how full is not greater than 10, right? Which is our maximum buffer size. So if both these things are true, that means, okay, we have room for the note, we can put it in the buffer. So what we'll do first is use this for loop to step through the array and check for an empty spot. And any spot with 0 we consider empty. So if it finds a 0, we know that's an empty spot. Put the incoming note in there. And all we have to do is increase our how full variable to indicate we have a note in the buffer, right? And that's how we're going to keep track of how full our buffer is. And then we're just going to return. So return just breaks out of the function and returns to the main program. And we're going to return true, which means that it worked. If we return false, if you remember, that means the buffer is full. So true means it worked. So if we get a note in value of false, that means, hey, that's a note I want to take out of the buffer. And we'll get our note number here. So we'll go down here. If note in equals false, go through the array one step at a time and find that note. Once you find that note, change it to 0. Next, we'll decrease the how full variable so to indicate that note was taken out. And then we'll return true, which means it worked. Now, if the note comes in and the how full variable is greater or equal to buffer size, which means that it's 10 or above, that means the buffer is full. We can't accept a new note, so return with false. So it's just going to jump out and say, hey, sorry, didn't work. Now there's one more part to this function, which is this. If note equals 255, purge buffer and send note offs. So a note value of 255 is a nonsense value, right? MIDI can only have 7 bits for its notes. So that means a note value can only go up to 127. So if a note value of 255 comes in, which is an 8-bit value, I know that that didn't come from my MIDI line. That came from the program. So if my program sends 255 as my note value, I'll know it's telling me to purge all the notes. So if note equals 255, go through the buffer, and for every space that you find a actual value, not a 0 value, send a MIDI note off command, and then get rid of that note out of the buffer. And then set how full to 0. That means the buffer is now empty. And that's how we're going to make sure that no notes get stuck when we enter our cheat mode. Now, here's the cool little trick I came up with. You notice these commands I have commented out. So I'm not going to want these running when I'm really using the program, but for troubleshooting, they're fantastic. So if I uncomment these commands, what I have is a MIDI Sysex command. So send Sysex means send system exclusive message. Now, like I said, system exclusive messages don't really have any format, right? It's up to the manufacturer to use them how they want. Now, the only thing a system exclusive message needs is it needs a byte at the start and a byte at the end. I think it's F7 and F0, and that indicates the start and end of the system exclusive. So the information we have to give our send sysex command are the values we want to send, and we do that with an array. So note buff is actually my note buffer array, my 10-byte array. So that's going to send the contents of that. I have to tell the command how many bytes I want to send, And of course, it's going to be the size of note buff, which is 10 bytes. So I'll just put a 10 here. And since I already described 10 into this variable, I don't have to write 10. I can just use this. And then if I change this at a later date, it will update here automatically. The last thing here, false, is a very important one. The MIDI Sysex command has a start byte and an end byte. And if we set this to true, the command will not include those bytes. So that means I would have to manually include them somewhere. I'd have to add a variable and append them to this array, which would be a real pain in the butt. But if I set to false, this command will automatically include the start and end byte to my message. So I don't have to worry about it, which is fantastic. What we'll see is when I uncomment these MIDI send sysex commands, I'll be able to see the contents of my note buffer in the MIDI monitor. And that is great because it's going to allow me to actually see what's going on within that variable. All right, so here we are back with our MIDI monitor. Now, you have to make sure if you're doing this that you actually enable Sysex messages, and you have to make sure they're not filtered out. So there's an option here to display Sysex messages in monitor. Make sure that that is set. Now, watch what happens when I press a key. Okay, so there is our note on command, 93C velocity 79. Here is our 10 byte buffer. Now, F0 is the start of the Sysex message, so that's part of the Sysex message. That has to be there. F7 is the end of the Sysex message, and that got added by our MIDI command when we added that false variable. Remember, we talked about that. So there it is. There is 3C in my buffer. There's my 10 empty bits from my buffer, and 3C is now in the buffer. If I remove that note, it is now out of the buffer, and my buffer is totally empty. So let's add a few notes. So let's add 5 notes. So I'll go 1, 2, 3, 4, 5. And there you can see, there's our 5 notes right there. And let's say I release them in a random order. So I'll release this middle note first. And there you go. You can see that that middle note is now 0. I'll release this one. And there it goes. I'll release this one. And this one. And finally that one. And now my buffer is back to clear. Okay, now let's do a test. Let's see if we can fill the buffer with 10 notes and cause it to overflow by trying to add an 11th note. So we'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I'll lean my finger over, and you can see the buffer right now is full. Every note is got a value. And if I add the next one, nothing happened. Right? That key did not send anything. So there you go. Once my buffer is full, no additional note on commands are coming through. And then if I release some, now I can go back to normal. There you go. It works. Perfect. Okay, so now that we understand the code a little bit, let's take a look at the schematic as it stands so far. So here is the Arduino Nano. I have the MIDI in circuit going into RX. I have the MIDI out circuit coming from TX. And I've got some power coming in to the VIN pin. So if you're powering externally, you can use a 7 volt to 12 volt DC adapter. But right now I'm not powering it with this. I'm actually just got the USB plugged in, and that's providing the power. But eventually, when it's a standalone unit, you'll have to power it externally. Now, one very important thing to mention is the jumper pins. So there's a little 2-pin jumper header right here. And if you've never seen one before, it's basically 2 of these little header pins with a little bridge that goes across and connects them together. So you can pull this off and separate those 2, break the connection, and put it on and connect them. You need to be able to break the MIDI input line. So there's the jumper pins there. If you don't disconnect this MIDI circuitry from the RX pin, you won't be able to send any code into your Arduino Nano. So basically this pin ties up the USB line and basically will make any upload fail. So you have to have a way to disconnect this, this MIDI circuitry from your RX pin while you're experimenting. Now, once you got the final version done, you probably won't need to reprogram it, but it's nice to have this jumper, so if in the future you want to change the code or upgrade it or something like that, you just have to pull this pin off and then you can upload the code, put the pin back on, and it will be back to MIDI operation. Now, the 3 push buttons I added, they're normally open push buttons. They're going to pins, digital pins 2, 3, and 4. One side's just going to the pins. The other side is going to ground because I'm using the internal pull-up resistors that the Arduino Nano has, so we don't have to add any external resistors. And there it is, not too difficult a circuit. This may change as I add more features to this project, but this is what we have so far. All right, guys, there you go, an update to the Cheetah project. Before we go, we got to thank our friends on Patreon. Thank you guys for helping to make this stuff happen. Let's play a little music on the way out and enjoy your names.